Good evening, and welcome to my garden with one of my telescopes. Been a lovely, hot, glorious day, but of course, in Selsey it generally is. Now, echoes. We all know about sound echoes, but did you know we can also have light echoes? I can assure you we can. The story really goes back to the year 1572 and the Danish astronomer Tycho Brahe. Now, Tycho was a remarkable man. He had a very eventful life, and when he was a student, he fought a duel, had part of his nose sliced off, and he made himself a new nose out of gold, silver and wax. Well, he was passionately keen on astronomy. Obviously, no telescopes. They didn't come along until years later. But Tycho set up an observatory on the island of Hven, and there he drew up an amazingly accurate catalogue of stars. It remained the best for a long, long time. A masterpiece of careful, accurate work. Come now to 1572. Tycho looking upwards at the starry sky. Of course, he knew all the stars perfectly, and he looked at the constellation of Cassiopeia. Well, you must know Cassiopeia. The 5 main stars make up a W on the far side of the pole star from the Great Bear. Tycho looked at them, and there was something else there. A very brilliant star where no star had been before. It became visible with the naked eye in broad daylight, and then, as the months passed by, slowly faded away and was lost. Until 1952, when the English astronomers Hazard and Hembury Brown detected a radio source in just the position where Tycho's star had been. We now know what that star was. It was a supernova, the sudden flare-up of a very faint star. Well, what's all this got to do with light echoes? Chris, over to you.
Thanks, Patrick, but don't go anywhere. I need you to represent Tycho Brahe.
Not Tycho Brahe, Tycho Brahe. And I've got his gold, silver and wax nose to prove it.
Well, I think it suits you, Patrick, and I know better than to argue with somebody who fights duels. But if you're Tycho down on Earth, then I must be the star that he saw a few hundred years ago. The year, in fact, is 5500 BC, and I'm about to explode, to go supernova. Light from the explosion is emitted in all directions, and Pete and Paul are going to represent 2 nimble light rays heading out into space. One of them, Pete, happens to be heading directly for Earth, but Paul's heading into deep space, or at least he is until he collides with a cloud of gas and dust and is reflected towards the Earth. Time goes by, and as we reach 1572 AD, the first of our light rays, Pete, is arriving at Earth, where he's observed by Tycho Brahe. Got it, Patrick?
I have indeed.
Excellent. So Tycho has seen the supernova, but it's not until 2008 that the second light ray, Paul, arrives at Earth and is observed by the Subaru telescope in Hawaii. And that's all a light echo is. It's a reflection that allows us to see light from the supernova many hundreds of years since it happened.
We are actually seeing the spectrum of Tycho Brahe's star.
That's right, and the spectrum's important because that's how we know the light came from the supernova. It has the same spectrum, the same fingerprints as light that we might observe directly.
Light beams, thank you very much. Well, light echoes aren't common, but there are other examples. And recently I talked about them to our 2 eminent guests, Professor Mike Bode and Dr. Tim O'Brien. So light echoes are really important.
I think quite excitingly, in astronomy we're used to being limited to one particular point of view of an object. We're sort of stuck here on the Earth and we're looking in one direction, so we tend to see things from just one side. But with a light echo, because the light's sort of travelling in different directions and then bouncing back off these other clouds around it, we actually get to sort of have a look around the back of something in space, which is quite a bizarre idea, but certainly gives us a lot more information about the 3-dimensional structure of these astronomical objects.
One picture I particularly like shows the exploding star V838. in the constellation of the Unicorn.
Yeah, I mean, there's a lovely sequence of images that were taken by the Hubble Space Telescopes back in 2002 when this star brightened suddenly. But what you see in these images is this gorgeous view of the reflected light scattered back off the material around the star itself. So when you see what looks to be expansion of material thrown out in an explosion, for example, that's not the case. All you're seeing is this sort of repeated scattering of light as it moves through the material around the star. It's really a beautiful sequence.
Other fascinating things too. I mean, RS Puppis.
Yes, RS Puppis is a well-known Cepheid variable. Their luminosity, the amount of energy they give out per second, is related to the pulsation period. And RS Puppis is a Cepheid variable with a period of around 41 days that is surrounded by gas and dust, and that gas and dust is scattering the light from the Cepheid. And you can see it illuminating this pre-existing material and waves of illumination spreading out from the centre.
So it looks for all the world like there's these sort of ripples of material expanding out, but in fact they're just ripples of light that come from the pulsing star at the centre.
Again, echoing the light variation of the central star.
Supernovae are unbelievably powerful. They don't happen often, but there are records of them going back a long way.
Yes, in fact there are historical records going back to several hundred BC. We have extremely detailed records, particularly from the Far East, of supernovae that went off in 1006 AD in the constellation of Lupus. The object is the brightest recorded stellar object ever. It was so bright that it was equivalent to something like the half moon, the first quarter moon, put into a single point. It cast shadows. It was even been said that at midnight you might have been able to read manuscripts by the light of this object. It was seen in daylight for a long time. It was seen at night for a couple of years or so.
But no records from Britain?
No records from the West, except for one, actually, which was from a monastery in Switzerland. The problem was that the dogma at the time in the West was that nothing above the moon changed. So if you saw something that had changed, that like a new star appearing, if you then noted that down, you might have been burnt at the stake. The same thing happened in 1054 when another supernova was observed, this time in the constellation of Taurus. It was visible in daylight for 23 days, visible at night for many, many months, and nobody in the West, as far as we're aware, noted it down.
The remnants are now detectable, both by visual and by radio.
The remnant of the supernova that we discussed in 1054 is the Crab Nebula. That's one of the most beautiful objects in the night sky. You know, it's 11 light years across now, 10,000 times the size of the sort of planetary solar system. And material expanding at 1,500 kilometres per second.
And very easy to find.
Indeed, I'm very proud of the fact that I found it myself with a small telescope from my back garden, actually. One of my major achievements as an astronomer.
I've seen it with binoculars in the same field with the star Zeta Tauri.
Wow.
Then comes to 1572, no doubt about that, the Danish astronomer Tycho Brahe. One evening, he looked up in the constellation of Cassiopeia a star that hadn't been there before. That he regarded as miraculous, and that was a supernova.
Yes, and that supernova, again, was extremely bright as a visible object. It was about as bright as Venus gets in the sky. And it was seen continuously and noted down in the West this time, particularly by Brahe, over a period of 18 months or so, until it faded from view.
Just very recently, a group of astronomers working at the Calar Alto Observatory in Spain imaged regions of the sky close to the site of Tycho's supernova, and they actually spotted these very sort of faint wisps of nebulosity. And in a series of images, they saw this nebulosity moving across the sky, much like the light echoes we saw earlier. And when you sort of point back to where they appeared to be moving from, it pointed directly towards the site of the explosion.
So this animation shows a God's eye view, if you like, illustrating what the light echo of 1572, what the cause was.
So here the supernova is just about to explode. It brightens and you'll see the sphere of light travelling out from the supernova. Some of it obviously goes backwards away from the Earth, but then reflects back off that cloud of gas in interstellar space. And so you've now got the sort of the first light that arrives directly from the supernova arrives in 1572 when Tycho saw it, and then the light that's travelled farther and therefore arrives later is just arriving now from the sites of these light echoes. You might think that we'd missed our chance to observe what was one of the closest Type 1a supernova there's been in our galaxy, and we know these things are fundamental to our understanding of cosmology now. But amazingly, this light echo phenomena gives us this chance to see effectively the same light that Tycho would have seen, but it's been on a longer journey. It travelled in away from us, from the supernova, bounced back off a cloud that's farther away, and is only now arriving.
Well, very informative indeed. Mike, Tim, thank you very much.
Yeah, thank you.
And now, what are we going to see in the night sky? Let's join Pete and Paul at my 15-inch telescope.
The appearance of a reasonably bright comet in the night sky is always a welcome sight for an astronomer. And this month we have Comet 103P Hartley, or Hartley 2 as it's known. Now, Hartley 2 should get to naked eye brightness about the middle of the month, but to be honest, this could be quite a tricky comet to see with just your eyes because it is quite spread out and diffuse. And I would recommend going out with a pair of binoculars to hopefully guarantee you a view. Now, locating comets can be quite tricky in the night sky if you don't know where to look, but there are a couple of pointers this month to help you find it. And on the night of the 7th and on the night of the 8th of October, Comet Hartley 2 passes very close to the famous double cluster in Perseus, the Greek hero. You can use the constellation of Cassiopeia to locate the double cluster quite easily using our chart, and this hopefully should help you find it. Point a pair of binoculars at the double cluster, and there you should be able to see quite close by this faint fuzzy patch, and that will be Hartley 2. But we're in for a real treat with Hartley 2 at the beginning of November, because on the 4th, the NASA Epoxy mission is set to do a close flyby of the heart of Hartley 2, the nucleus of the comet. Now, we're covering that in next month's programme, and if everything goes to plan, this should give us our first view of the nucleus of Comet Hartley. That should be absolutely fantastic. Now, I've mentioned the constellation of Auriga, the charioteer, and just below that is another familiar constellation known as Taurus the Bull. And at the start of November, in the first week of November, there is a meteor shower which should send out meteor trails emanating from that constellation. The shower is known as the Taurids, and it's not a particularly active shower. It's got quite a low rate of meteors that you're likely to see. But what makes it really interesting is the fact that you often get mixed in with the normal meteors some bright fireball events. So it's well worth keeping an eye out in the sky if it's clear throughout the first week of November. So Paul, what will you be looking at throughout October?
Well, do you know, Peter, I'm actually going to be making lots of observations of the planet Uranus.
Oh, right, OK.
It's had a bit of a bad press, the planet. I feel sorry for it in a way. And it's been well south for British observers, but now it's moving back up and becoming quite a viable target.
OK, and it's quite easy to see as well.
It is very easy to see. It's very near to the planet Jupiter, so we've got a little guide. And, you know, it's one of those planets that's got this bad press of being dull, bland, uninteresting, but that's really just become sort of astronomical hearsay, because nobody really observes it on a regular basis.
Well, it's an awfully long way away, so it presents a very tiny disk.
It does. It's just under 4 arc seconds, so it's about the same sort of size as Jupiter's great red spot.
That is quite small, isn't it?
Very, very small. Yeah. And it is true you will need a larger telescope to get anything out of it. It's visible with binoculars, naked eye almost, but you'll need a large telescope to see the disk or any details on it.
What sort of things could you see on it?
Well, with my 8-inch reflector, I have been able to see this beautiful sort of bright equatorial band some cloud structure and a couple of the brighter moons, but that's about it. And if you want to see much more, you'll need a much larger telescope, something like this.
I took a picture a couple of weeks ago, and it did show a sort of light band through the middle. But I took a picture last night as well, and it doesn't show that anymore.
It's very interesting. Actually, the planet has shown complete changes in magnitude over the course of a period of observation. So we don't really know much about it. And as it's being sort of neglected, if you like, a little bit by professional astronomers, if we get amateurs to get out and look at it, then, you know, it might be amateurs that discover that it's actually quite a dynamic world, but go through these periods where it's very quiet.
But of course, one of the problems that I have when I'm looking at Uranus is that there is something much more tempting very close by.
Jupiter right near to it, yes. What a wonderful world that is. One of the things I like doing, and it's of no scientific use at all, Pete, but I do love watching the satellites transit across, look the shadows, you know, it's beautiful. And in particular, there's a nice one on October the 31st, about, if you're up at sort of 3:15 in the morning, where you'll see Ganymede and Europa transiting the disk. Ganymede will be almost finished, Europa will be just starting, but I think that'll be quite a beautiful thing to see.
That's a fantastic thing to watch. I mean, that gives the whole system a three-dimensional feel.
It does. You really do feel like you're looking at a planet and its moon. It's great stuff. But amazing. Jupiter's not the only interesting thing in the sky, is it?
It isn't. There's a variable star called Myra, a name which means wonderful, which is actually coming to maximum right in the middle of this month.
It's a beautiful star, isn't it? Beautiful red colour.
It is, and the variable period is 332 days, which is almost a year. At its dimmest, you need a pair of binoculars to see Myra, but at its brightest, you can see it with just the naked eye. So it adds an extra star into the constellation of Cetus.
Because it's a very, very barren constellation, isn't it? There's hardly anything there.
So it's well worth going outside to see whether there is an extra star in there. The beauty about Myra, actually, is you never know quite how bright it's going to get.
Well, hopefully I shall manage to catch it, because most of the time I've looked at Myra, it's been dim, and I've always managed to miss the maximum.
Well, middle of the month.
I should be out there looking and hoping.
Now, if we return to the solar system, Chris has got some quite exciting news about the planet Mars.
Well, I thought we'd start with Mars for our news notes this month, Patrick. In particular about Mars's moon, Phobos. Phobos is a weird world, as you know. I mean, it's lighter than it should be. Perhaps it's hollow or something like that. But we've never known what it was made of. And the European Mars Express spacecraft has taken a close look. It's been trying to work out how Phobos formed. It was thought that it was an asteroid that had been captured by the red planet. But Mars Express tells us that its composition isn't like that of any asteroid we know of, nor is it anything like any of the meteorites that we have down here on Earth. So Phobos could be an unusual asteroid, a whole new class of asteroid, or it could have formed when something hit Mars's surface, throwing material up into orbit, which then coalesced to form Phobos, just like our moon formed when something very big hit the Earth.
Well, a new kind of telescope being built.
That's right, Patrick, and I helped build it. Other people did most of the work, but part of this telescope is just up the road in Hampshire. It doesn't look much like a telescope. It's made out of the kind of things you'd expect to find in a garden centre. It's called LOFAR. It has important antennas, and it's looking for low-frequency radio waves. And we take the results from the UK station and from about 40 or so other similar installations all across Europe, mostly in Holland, actually. It's now working. I can't wait to see the results.
Well, Chris, we are coming up to a landmark. Not quite yet, but very soon. It'll be our 700th Sky at Night programme.
Well, Patrick, we wanted to make the 700th programme special, so what we're planning to do is put you, the viewers, in charge. We're going to do a question and answer show and have a whole set of eminent astronomers there to answer your questions about the universe. So if you'd like to submit a question, go to our website, www.bbc.co.uk/skyatnight. If you don't have access to the web, you can send in your question by post, and while you're at it, get your Sky at Night newsletter. Send a self-addressed envelope to newsletter number 119, The Sky at Night, BBC Birmingham, the mailbox B11AY, and we'll do our best to answer as many of them as possible on our 700th programme next March.
Well, next month when we're back, we're going to talk about comets. And so, from my darkened garden, good night.